what I have here is the body of the metal detector built. Now, of course, the project's actually still on the workbench. Turn on the light here. I got a pulse induction circuit going on right here. Seems to be sensing coins up to like about 15-20 centimeters. Larger objects up to, a foot or two, depending on the size. But so, as far as the handle and stuff goes, I got an armrest there. Got the grip. So, hand goes there, and then you can hold it like that. It's not going to slip out of your hand. Of course, for the armrest, if I get my arm in this without making my arm look funny. So this is all just PVC pipe I used. And this stupid camera. So I used toilet screws because they're plastic, nylon, whatever the hell they are. Because you can't have metal near the search detector, of course. The actual base of this right here, the coil's going to fit in. Found out I cannot glue to this because this is made out of polystyrene. This was actually cut out from this here bucket. This is one of those work buckets you mix cement or whatever the hell in. I cut this up with tin snips, the bottom off and the top, and that's actually what this is, the bottom. So the search coil is going to fit in here. So you can see there's a little bit of space go all the way around in the flat edge right there. I use jumbo zip ties to tie this. There is one glue that actually will stick to this, and that's Gorilla Glue, but just barely. I just use that to hold on the base. This is all tin snip job. The actual mount right here, made that out of tin snips. Got some rubber pieces there, so you can tighten and loosen this and it won't slip. And then let me grab this real quick. This right here is the bottom section. So this will, once again, one-handed here, this isn't the easiest to do. This will sit on top there. And since I can't really glue to this, because no glue will stick to this kind of plastic, I found out the hard way. What I did is I drilled holes all the way around there. And on the inside piece too. So you can see. And I'm just going to zip tie this thing together. Because why not? I mean, I'm already using zip ties to hold, jumbo zip ties to hold that. So I have to zip tie the whole damn thing. And it'll hold the bottom on. It won't technically be waterproof, but the coil will be, because the coil will be sealed up. And I figure if I take out in the water or something, I can just put a bag, trash bag or something over this, just wrap it down. And then it'll technically be waterproof. So the other thing I did is, let me pull this out. Screw. I'm going to have to drop this on the floor because it's all one-handed. I do have two arms, just one needs to hold the camera. One of these days. Alright. So, this entire thing, I put set holes all the way across. So this thing can be adjusted. Put that on the ground there. Can be adjusted from like 3 feet, like kid size, or if you gotta detect something really close up, all the way the hell out here, and so on. Now you'd think, why the hell would you need something that long? Your arm's not that long. Well, I'd like to actually use this in water. And, you know, so I can dunk this a few feet in water. And you're going to need that extension for that. So the other thing I was going to show really quick. We got 7 volts on the meter right here. And this is, you can see my probes right here. This is coming off of the voltage directly from these batteries. So both these batteries right now are providing about 3.5 volts, which is, I believe, about where a normal charge would be. Well, now it dropped a whole big millivolt, big deal. I've been, you know, after charging these batteries, I've been running these batteries on this circuit now. This whole metal detector, just toying with it and having my fun for probably a good hour. And it's only dropped from about 7.2 to 6.98. Now for this DC to DC converter to go out of whack, where it no longer gets the amount of voltage it needs to actually operate and convert the voltage where we want, this would have to drop all the way down to 5 volts. That means each one of these 18650 batteries, and just for, you know, if anybody ever wonder what these look like, I have, you know, my texting radio actually uses one of these too. A lot of electronics are using these kind of batteries nowadays, and not just the oddball looking ones I have. But for these batteries to get to that point, I mean, you'd be really kind of hurting the battery's lifespan. But when they get down to about 3 volts a piece, I mean, we're at 7 right now. So that's the main battery drain right there over an hour. Maybe what, 200 millivolts? 7.2 to 7 volts, yeah. So now we're going to take our probe here and let the metal detector get wacky. We're going to measure the voltage output now from the DC to DC converter. So now this should be stabilized and 10.39 volts. Now the reason why that dropped a little bit, normally I had this set to about 10.5 volts. It seems that's where the circuit wants to run. I can adjust that, of course, with the precision trimmer. But, you know, as long as we're in the territory between, let's say, 10 volts to 10.5, or, you know, plus minus 500 millivolts, the metal detector circuit itself is stable. Stable as can possibly be. I was thinking I was going to need a voltage regulator, and I actually went through the process of trying that. I used a, well, can't see the number, but it's a LM337, or an LM137 would work too, where you can adjust. It's an adjustable voltage regulator. I had to use a negative rail on that one because I didn't have a 117 laying around, but that's one way to do it. The thing is, with those linear regulators, they draw a lot of current and you're just wasting battery. This is actually the better option, because this is simply just boosting the voltage. I mean, this whole thing is like pulse, right? I mean, we're going from the batteries to a DC to DC power supply, which is also pulse. I mean, we're sending pulses into an inductor, which creates a higher voltage. This is basically the power supply right here. The battery in this is the power supply. I mean, we could just take these wires off and run into a bigger battery if we wanted, but it's just funny to me that it's like this is also a pulse circuit in its own way. Go into a pulse circuit again, and this pulses the coil, the detector coil, and then we have an actual detector plucking off the pulses, which then becomes the actual metal detector itself. And like, you know, we got metal here, and, you know, voila, we got a metal detector. So it's like this whole thing is pulsed. Even the amplifier for the speaker itself, that's the transistor right there, which isn't even biased on at all. There's no bias going to this. It's basically biased off, and it just takes a pulse from the OP amp stage, and then we'll show that quick. This is the basic circuit right here, what they call the Pirate Pi metal detector. This is a Russian metal detector circuit. Came out of Russia, supposedly. I mean, this is what's happening here too. Another 555 timer, 555 timer, trace of pulses. Transistor buffer goes into a MOSFET. Pulses the coil. That's our metal detector coil right there, L1. It's the big coil. That's the, what is it, 400 UF millihenry, whatever. That's then plucked off through the diodes, which regulates it. Goes to the first OP amplifier, which is magnifying those pulses, and then it's plucking off, basically, it's biasing and plucking off the positive pulses, riding back through the timing. Even this circuit kind of has me scratching my head a little bit, but it's working. And then we're simply going from the last OP amp, same chip, by the way, standard 8-pin dip chip or whatever, and then we're going to a transistor, which is biased off, and then it just saturates this transistor, goes into the speaker for the pulses that you hear, that it detects over here. So this coil, L1, injects a pulse into the ground, and then the pulse that comes back when there's metal being detected, almost like an echo, comes back when this MOSFET is turned off, and it allows us to be detected, and then it goes through the biasing, which allows it to be plucked and then heard via the speaker. Now I did a few changes, of course. I added a volume control over here and changed the speed. One thing you can do too with the two resistors on the 555 timer, you can adjust those for pulse width, which allows you to potentially kind of discriminate different metals, and then of course the speed itself, which I find the speed actually seems to have a larger effect on what kind of metal you're detecting. I notice the faster the speed, the more battery drain. However, it seems to have a different kind of resonance when it gets echoed off the metals. So maybe there's a way there to actually be able to discriminate different kinds of metals using one of these, because these sort of metal detectors are not known to have discrimination, unlike the VLF types. Alright, now we'll try the penny. It's more sensitive to the penny, actually. That's a foot away. Highest sensitivity right there, but that's a foot away. Wow. Okay. Check this out. Keys. Standard set of keys. I actually have to set, well, I might have to set the sensitivity down. It's getting too much. Okay, put the sensitivity down a little bit. See if the frequency matters. Turn that up. The only thing is self-oscillates a little bit. You really got to narrow in that sensitivity control. I'm going to have to use a precision trim pot for that. Alright. Washer. That's probably like about 6 inches away. And just for shits and giggles. Easily 2 feet away. I mean, don't even have to try. But it does seem to work better on lower frequencies. Crank it back down. Trying to change this control. Look at how far away I am. This is crazy. That's probably like, yeah, that's like 4 feet. Well, 3 feet. I'm gonna say like 3 feet. Let's see here. Let's see, that'd be 1, 2. So that's like 3 feet right there.